Welcome to Review Recording 1A and B, which accompanies instructional recordings 1A and B for Mathematics 2200, Unit 3, Chapter 3, Section 3.3. We'll do a couple of examples here on completing the square to convert from standard form to vertex form of a quadratic function. Here we have a multiple choice style question. What is the equation of the function y equals negative 2x squared plus 8x minus 1, written in the form y equals a outside of x minus p squared plus q, which is really vertex form. I'll do this problem by completing the square. We group our first two terms. So we have negative 2x squared plus 8x minus 1 out here. Then we have to remove the negative 2 as a common factor. So we take that out, and we have x squared minus 4x left inside the brackets. Next, we have to create a perfect square trinomial inside those brackets. So I'll make a blank here, and whatever we add in, we have to subtract off inside those brackets. Now remember, a perfect square trinomial has this format, and therefore these factors, x plus d squared. So this middle term, right here, this negative 4, that's twice the value of d. So that means d is equal to negative 2. And in this blank, our value of d has to be squared, so it's negative 2 squared, which equals 4. So we have to add 4 there, but balance it off by subtracting 4. Now before I can move that minus 4 outside the brackets, I have to multiply it by negative 2. So I've got y equals negative 2 outside of x squared minus 4x plus 4, and we have plus negative 2 times negative 4. So I've written that out here and subtract our 1. To finish off, we have y equals negative 2 outside of, factor the brackets, it's x minus d, or x plus d squared, that's x plus negative 2. So it's x minus 2 squared. Negative 2 times negative 4 is 8, minus 1 is 7. So B is the correct answer. Please bear in mind this problem could have also been done by recognizing that the a value must be the same in the vertex form as it is in the standard form. Well, that doesn't help us narrow things down here. But then you could also use negative b over 2a to get the vertex and compare it to the correct vertex from the vertex form. In our next example, we have to put the function in vertex form by completing the square, and then sketch the graph showing at least 5 points for accuracy, including the vertex and the y-intercept. We have y equals negative a half x squared minus 2x that gets grouped plus 5. Now, we take out the negative a half. Now, taking out a fraction is always tricky when we take it out as a common factor, because we've got to ask ourselves, in this case, a half of what will give me 2? Well, that would be 4. So I need to have a plus 4x here, because negative a half times positive 4 would be negative 2. We also, in our next step then, have to create our perfect square trinomial. So we make our blank here and subtract an equivalent amount in the next blank. This 4 is twice our d value, so 2d equals 4. That means d equals 2. D squared is equal to 2 squared, which is 4 for this blank. Whatever I add in, I've got to subtract off. Therefore, I've got y equals negative a half outside of, keep the perfect square trinomial part inside, x squared plus 4x plus 4. The minus 4, before I can move it out, I've got to multiply it by the -1/2 plus the 5 that was already out there. So in short, that gives me y equals -1/2. The factors of the perfect square trinomial are x plus 2 squared, x plus my d value squared, and then -1/2 times -4 is +2 plus 5, which is 7. Now by moving some things over, I can probably squeeze in a table of values here. Starting with my vertex, that's the easiest one to start with, -2 and 7. I'll also use -1 and 0. Now the 0, when I put 0 in for my x value, it's easier to put it in this form. That way I can see that my y-intercept is going to be 5. So I got a y-intercept of 5. I've got a vertex at -2 and 7. We know this graph opens down. Just need to calculate the y value when x is -1. And that works out to be 6.5. So at -1 and 6.5 I have a point. So since my vertex goes through -2, 7, my axis of symmetry is x equals -2. So I've fulfilled that part of the problem. Now I've got points on the other side of the axis of symmetry to get the remaining points that are required for the problem. So that's at least 5 points, and I can now sketch my graph. Something like that. Put some little arrows on there, and now I have my sketch with all the required points. So when converting from standard form to vertex form, group your ax squared and bx terms using parentheses, remove the a from the parentheses as a common factor, create a perfect square trinomial, making sure to subtract a value equivalent to what was added to create that perfect square trinomial, and factor the perfect square trinomial.